All right, let's go ahead and get into it. Hello, my name is Dr. Richard Watkins, and this is the Richard Watkins podcast. And we've got a very, very special guest with us today, and I will tell you all about them here in a second. But first, we have to do an introduction to who made it possible for us to be here today. We have to thank our sponsor for today's episode, which is the Science Policy Action Network. And I'm still new to this, so I actually have to still read the blurb. So, audience, please forgive me. I'm getting better with time. It's kind of like flying the airplane as I'm building it. So, bear with me. We are the premier lobbying and consulting firm specializing in education, innovation, and health. Our mission is to drive impactful policy change and foster advancements in these critical areas. At SPAN, we work closely with educational institutions, healthcare organizations, and innovative startups to navigate the complex landscape of policy and regulation. In addition, we help organizations manage the rapid changes brought about by innovation. Our team brings scientific expertise to the table, aiding organizations in making informed decisions and seizing new opportunities. Whether it's advocating for improved educational standards, supporting groundbreaking health initiatives, or fostering innovation in technology, we are committed to making a positive difference. Our team leverages a wealth of experience in public policy, science, and industry to provide strategic advice, advocacy, and support to our clients, ensuring their voices are heard and their goals are achieved. If you're looking to partner to navigate policy world, manage innovation, and make scientifically informed decisions, SPAN is here to help. You can learn more about us and our work by visiting us at www.span-inc.org. That is www.span-inc.org. Now, with that out of the way, let's get to the VIP, the person of the hour, Dr. Tiffany Barnes, Distinguished Professor. Dr. Tiffany Barnes is a Distinguished Professor of Computer Science at NC State University. She received her BS and MS degrees in computer science and mathematics and the PhD in computer science from NC State, a member of Phi Beta Kappa and the NC State Golden Chain Society. She is CERD ACM CIGSSE. Whew. It's hard to get these acronyms right sometimes. IEEE, Special Technology Community on Broadening Participation. Um, the International Educational Data Mining Society, STARS Computing Corps, and the International Society for AI in Education, and IEE Transactions on Learning Technology. Dr. Barnes received an NSF Career Award for novel work in using data in education, educational data mining to add intelligence to STEM learning environments. Dr. Barnes is the co-director for STARS Computing Corps, a consortium of universities that engage college students in outreach, research, and service to broaden participation in computing. Her research focuses on AI for education, educational data mining, serious games for education, health and energy, computer science, education, and broadening participation in computing education for research. That was a lot. It made me sweat as I was reading it, but listen, how did I do? Hopefully, I covered everything. Did I leave anything out? And should I call you Distinguished Professor or just Tiffany? How do you prefer it?
Uh, pref- Tiffany's one.
Excellent, 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 Tiffany. Well, thank you so much for being with us today. Listen, AI, artificial intelligence, is on the tips of everybody's tongues. It is the from barbershops to classrooms, everybody is talking about it. But before we get there, how did you get into computer science?
That's a great question. I was a student at the North Carolina School of Science and Mathematics, which is here in Durham, here in North Carolina. It's in Durham. And they have 11th and 12th grades. It's a residential program. that's part of the UNC system in North Carolina, and they required at the time, and hopefully still require every student to take an introductory computer science class. And when I took it, it was basically taking all the math that I knew and getting a computer to do it, which I thought was great because it saves all of the repetitive efforts of a procedure, right? So once you learn a procedure, you can write code to take that procedure and put it on a computer, and then you know that all the steps are going to be accurate. So I fell in love from day one with computer science and the idea that we could use computers to make our lives easier and more efficient.
Now, when you were a student at NC School of Science and Math, at that time, were you thinking that there was going to be this thing called artificial intelligence? I mean, we see it on television, in movies for quite some time, since before the 80s. Were you already thinking about artificial intelligence then?
I mean, honestly, yes, because I've always thought of anything that helps me do things that I want to do as a human as kind of like an augmentation for a person, right? So when I use a computer, when I was saying like, oh, I can take a process that I use and I can automate that process so it's repeatable, in a way, that's already in a broad sense artificial intelligence. I'm taking something I know is going to work and I'm implementing it on a machine. Computer is a machine, and I'm getting that machine to do it for me, and it's doing an intelligent thing. So in a way, yes. And I was already always a big fan of science fiction and fantasy writing. And so I'd already read some books about, the coming of AI and, lots of back then, the idea of AI was more about sort of robots with brains, like kind of like artificial humans, where that could walk and would have brains like people and talk like people. But we've had this evolving idea of what AI is and what it entails over the decades, since before I was working on it. But we now have a lot of technologies that work together, that could work together, that kind of give you all those different pieces of intelligence, right? We have people working on robots that can walk in a way that's similar to humans. We have ChatGPT and other large language models that can have a conversation like people do. But we also have basic systems that are running on the web all the time that are decision algorithms. And those are, I consider all of those things to be artificial intelligence. So when we're using a machine to do something that a person used to do or a person could do, then it all falls under a very large umbrella of AI where we're using machines to assist people in doing tasks that require some intelligence.
You were going off of that, you're talking about tasks. You also do work or research into kind of the merger between artificial intelligence and education. Are you doing that at just the university level? Or are you doing it K through 12? Tell us a little bit about education and artificial intelligence.
That's a great question. So, the center of my research is in leveraging artificial intelligence to improve education, specifically within educational software. So, my PhD and my National Science Foundation Career Award were all focused on taking data from students interacting with an educational software and then using that data to provide help to students. So in my mind, I was imagining, I always imagine things like, okay, I'm in my room, I'm working on my homework, and I run into a problem. What am I going to do? Maybe it's the middle of the night and no one else is awake. So I can't call my friends. I can't ask the instructor. I want to be able to have the software leverage the fact that it's been collecting data from people using this software for a long time, doing the same problems in the same class. So there's a lot of common things that go on while students are solving problems. And what my research has focused on is finding those commonalities and using that to be able to take past student work to recommend future paths for students and do things like determine when someone needs help. So that's like the primary focus for my work. But I've also done some work where we actually are learning to teach kids about AI. So I was a collaborator on a project to create a new course called Computer Science Frontiers, which you can find at csfrontiers.org. And it's a curriculum for a high school course that only needs a prerequisite of a CS Principles course, which isn't like an introduction to block-based programming or any other kind of programming, but it's an introductory course. So it's a second course in computer science, and it covers distributed computing, which is like playing multiplayer games or passing messages and that sort of thing. It also covers Internet of Things, like controlling robots with your phone. And the module that I helped contribute was the AI and machine learning module, which introduces students to AI and machine learning. And they play with a number of online tools like Quick Draw and learn about how AI works and talk about bias and ethics in AI, because I think it's very important for everyone to understand how AI and algorithms are working so that we can have a public conversation about what should AI be used for, who should benefit from it, who should be able to get data from AI. If we don't have everyone learning about how AI works and learning to be creators for both software and computer science systems and artificial intelligence, then people can't really have a good, effective conversation about what these should be doing, who they should be serving, how they should be used, what data they should be allowed to have, and that sort of thing. So I really believe that everyone should be able to learn to be a creator of technology and be able to have conversations about how technology ought to be used.
Yeah, let's talk about that gap a little bit. Like, what's the consequence of not having these conversations, schools not talking about it? I talk to schools all the time and they reveal, oh, we're not having any conversations about it. Or I bring it up and like, oh, that's interesting. Especially when it's like advancing so rapidly. What are the consequences of schools not having these conversations? And what are the consequences of the public not having these conversations?
I mean, they're dire, I think. We really need to have these conversations. And if it's not at school, then we're not going to be involving our entire population. We already have a huge digital divide where many people don't have as much access to internet devices and AI now, which costs money for the best versions of AI. Um, and if people don't have access and people don't have conversations at school, that means they're at a deficit when it comes to the workforce. Everybody in the workforce is using computers, they're using algorithms, they're using AI. Even years ago, even before this wave of AI, I saw an ad for a dog catcher job and it required use of databases, right? Like you can't do anything without a computer. And now, since we all have computers and now we all have the internet and we all have access to these huge data repositories, it's becoming more and more pervasive that every system uses AI, or at least large data sets and algorithms that make decisions that are independent of what humans are doing. So this has to happen. It has to happen at all the schools. Otherwise, we're leaving people behind, and we can't afford to do that.
Like, you touch on something really interesting, and it kind of about like what is the consequence of not really having these conversations. And one of the conversations that I've been interested in having is with the impact that innovation in general is having on society, AI specifically. What what are we training our kids to do, right? Hope I'm saying that right, right? The world is changing so rapidly. The workforce, the market is just not going to be the same by the time, say, for instance, a kid that is in third grade graduates from high school. Like, everything is going to be different. And I sometimes wonder, what are we training our kids for, with the markets and with the labor force changing so quickly. You talked a little bit about how you had to be able to navigate computing and data, mining and so on and so forth to be a dog catcher, and that's now. Like, look 10 years
That's
into the
even in
future,
the
what are we
past.
training? Yeah, what are we? I don't understand what are we training kids for?
Well, that's a great question. I want to answer that in a couple of different ways. One is a lot of times when we think about education, we remember what our education was like, and then we start getting upset about what might be going on in schools. The schools have changed, and some of the schools are talking about AI. So I have been I was just at an AI forum about a week ago where there was teachers across the country talking with thought leaders about AI and how it should be addressed in schools. So people are having those conversations, and decision makers are working on that. It just takes a long time to propagate the newest innovations into schools. And there are many, many people sort of making new curriculum to integrate AI into schools and into the tools that students get to use. So I think that those conversations are happening. They just take a long time to spread. And also right now we're talking about early adopters are in the schools. They're using AI with their kids. Even the changing landscape was mentioned at the forum I was at last week, that was hosted by the National Science Foundation Engage AI Institute. It was an event hosted at the Friday Institute at North Carolina State University. And one of the things that was mentioned was, oh, our school was already embracing the use of open AI, but they changed their platform rules so 13-year-olds couldn't use the platform. So they had to stop. So we're all looking at legal challenges. Schools are trying to protect the data of their students. They know that these large language models consume the data that gets put into them. So they have to make sure and protect the students that their data isn't put into a system that then can use it for whatever we don't know. So you can understand why they're cautious, and parents are cautious because people don't understand what AI is, and they don't know what's going to happen if they consent to the use of AI. So people who do AI work and who sort of help propagate these AI systems, we have a responsibility for teaching people about what these systems do, what are their purposes, and what are the impacts, so sort of the benefits of using an AI, and what are the potential costs. One cost that we always want to make sure is mentioned is that large language models and other newer AI systems take an incredible amount of energy to use. Right. So we might think, oh, well, I've got a computer to do this task, so it costs nothing. But it's not true that it costs nothing. There's now electricity being used to do all these tasks. And since so many people are using them, there are more and more server farms that are needed to run the computing systems that we need. And that's having an environmental impact, has a cost, right? We're already raising the temperature of the planet, and we have climate change, and it's here and it's now, and we're making it worse by the use of computers. So we really have to address that. But just going back, like, what are our kids learning? They are learning that they can get information out of systems. So a lot of them, even if they're not learning it in school, they have devices. Like I said years ago, in 2020, over 77% of all middle schoolers had access to some device that had internet. So that's years ago. They still even probably hopefully have more access. And that means they know about AI. They're using it to generate images. They're using it to ask questions. And I've seen research papers come out that say that actually a lot of times these conversational agents are better able to help students because they already interact in an interaction mechanism that the students are familiar with, right? We all have been talking since we were small. And so having a conversation is a way that you're familiar with getting new knowledge and sort of being able to ask questions. So if I say, hey, Richard, what's a podcast? And you start telling me, but you use some words I don't understand. I can say, hey, can you do that again without using the word, media or whatever. And kids know how to do that. So if you remember, we all had to be taught how to do an internet search, right? But since you've already been taught since you were small on how to have a conversation, these large language models enable you to be able to do some things that were harder with Google search, for example, or other kinds of search like Bing or other engines. And the other thing you can do is contextualize. So we've also learned a lot about prompt engineering, right? So if you ask the question, like if you steer the conversation in a certain way, like pretend I'm a college student and I'm studying for a calculus exam, please teach me about integrals, right? And then the language that I'm getting out of a conversational agent will be adapted for a college level course for the topic that I want, instead of, oh, I went and did a search and I found something, but maybe it's the latest research on calculus and it's not useful for my exam. And I have to filter through that. And that means that you can get access, everyone can get access to information that might have been behind a wall of sort of understanding the framework where it was presented or being able to sift through irrelevant things. So what are kids learning? They're learning both what's happening at school and they're learning what's happening in the world. They see videos, they talk with each other, they've seen the news, their parents are talking about it. It's not invisible to children. So they're learning both things and they're like, oh, there's some different things going on. School has this stuff and internet has this stuff. And they're learning at school some that there is a curriculum that talks about trust of information, and it needs to be updated with what's happening with conversational agents and large language models and what will be large multimodal models that will also be able to bring in images and sound and text at the same time.
What happens when what happens when AI does the job better than us?
That's a great question, and it's probably the most frequently talked about question about AI. So, in reality, AI often will do a job better than us, but people are valuable. So, I think the reason why the conversation, like people learning about AI is so important, so we can have conversations about what it means to put people first, right? So, yeah, maybe an AI could do a better job, and often people have been replaced by what I would consider in a broad sense AI. So, for example, many systems for providing social services or medical care for states, for example, have been offloaded to companies that have built software that handle sort of enrollment, registration, all the paperwork and bureaucracy associated with providing services. And many of those systems then implemented algorithms that were decision making, like, should we cover this or that? Is this person enrolled in the program or not? And there have been inequities. I think there's a book called Automating Inequality that gives some great examples where such systems were implemented in states, and then sort of the company that was contracted with a state sent out a mail to everyone, a paper mail to everyone that said, you got to re-enroll in our new system, and if you don't do it by such and so date, then you're out of the state system. Well, what about people who were in a coma when that mail went out? It's not better for an algorithm to make this decision than a human, right? So people got automatically kicked out of their enrolled state health plan, that they were in because they didn't do a thing to be in the next system, which was automated. So sometimes people are better and sometimes machines are better. So what we really need to do is figure out, when is it important to have a human and when is it better to have an AI? And then we need to teach people to be able to work with AI so we can take human capabilities and compassion and apply them when an algorithm just isn't what we should be using.
So people are interacting with, AI just all the time. And at times it is indistinguishable. When we're talking, you can easily differentiate, and just in our conversation, all right, this is a machine, this is AI, this is a person. But in many people's experiences, they don't know whether or not they're interacting with a person or with a machine. So I guess the question that I'm going to ask is, when do we cross, for lack of a better term, the Rubicon, where the line, you're smiling, you're like knowing where I'm going to go, where the line between what is human and what is machine is erased?
Well, I think there's a classic test in computer science called the Turing test, that was established by Alan Turing long ago to say, okay, we will have accomplished AI or some sense of AI when you had a chat conversation with an AI agent and you couldn't tell if it was a human or not. I think we may have passed that. So many AI systems over the years were built to try to pass that Turing test. And it was just maybe 10 or 15 years ago that the first system passed the Turing test. And it only passed because it passed itself off as a 16-year-old English as a second language speaker from like Russia or something. I'm just making this up. I can't remember. It was something like there were conditions on the chat is by a not native speaker, not where you're from person. And then it was able to pass the Turing test. But now I think, we might be there. Although I have seen some research papers where people were sort of classifying AI analysis of human essays, or actually rewritten human essays. And then people read them and rated them, and they're like, after a while, you can tell which of these essays were written by a chat, an AI agent, because these large language models are actually built to predict the next word. And they're built on sort of the corpus of like everything that you could get on the internet, including like probably copyrighted stuff that shouldn't be having access to. But it's a predictive model. And so in many situations, just like a human can do, when someone says like 6 words, it's pretty easy to guess what the next word is, especially if it's the. But many times, a human already kind of knows what the frame of the sentence is going to be. And you can see that in the chat and the sentences generated with generative AI these days. And so, for example, if you have it write an essay in the last paragraph, it's going to say, in conclusion, blah, 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 blah. And, but it always says that every time you ask it to write an essay. So, you can detect some of it. I think anytime you're interacting with a system that could be automated, you should assume that you are interacting with an automated system. So we already passed the point where you probably couldn't tell, but I've noticed when I'm using like chat agents on a website, when I'm trying to purchase like plane tickets or get some customer service or something, many of them have already said, "Hi, I'm the Frankie chat bot that's going to help you with your system. I can answer your questions. What is your question?" And then you can tell it's a bot, right? But also, before we had this, people who worked in these customer service interaction jobs already had scripts. They already had sets of chats to copy paste into the chat, right? So we've already been interacting with already decided interactions, like what, people already thought about. What are all the questions someone might ask in this situation? Let me come up with most of the answers. Let me put them in a system and let me try to help people get to those answers faster. So in some sense, if you're trying to find information, you probably should be happy if you're interacting with a bot that was specifically designed for the situation that you're in, because that means hopefully you'll get the information faster. Now, when we don't want to be interacting with a bot, it's when we think we're forming a relationship, right? So if you feel that like, you're trying to make a friend or you're trying to build trust, if you are then facing like interacting with an agent and you don't know it, then that can be harmful to you because you may make assumptions about whether or not this agent that you're interacting with cares about you, whether they're going to protect your interests, whether they're going to steal your data, and that sort of thing. And that gets into some issues related to like cybersecurity, because one of the biggest dangers, and kids have been learning about this in school for a while, is that there's a thing called social engineering that people use sort of social concepts and information sharing and trust building and things to get your trust, to get your information, to get your data, to steal things. So that is where I see one of the biggest dangers is places where there could be relationships, or places where there's interfaces where someone may get enough information about you to then be able to sort of circumvent any security you have or be able to get your data. So I think we should just assume we're almost always interacting with agents. If it's to a company's benefit to put an agent in front of you, they're going to do it. And so you should always be on the lookout that you probably are interacting with agents.
Sometimes like when you interact with the agents, it's actually like kind of positive. Like you're just like, man, that was pleasant. How many times, I mean, I don't know how many times I've called like a service provider and there's like a human on the other end and they seem almost aggravated that I'm like calling them looking for like help. They're like, how can I help you? They're just giving you like attitude and stuff. I'm like, I'm already coming to you with an issue with the product or with the service, and I have to go through you. But now with like, with an AI assistant on the other end, you just don't have to deal with that anymore. And I remember I used to go to places and businesses and so on and so forth, and maybe receive less than optimal service or attention. And then I talked to my wife, and I'm like, man, see, this is why we're going to be replaced by AI. It's because the consumer is going to enjoy the service provided, by that AI system. And one other thing, if I could just bore you with this story, and it was like 9 years ago. I used to work at the University of North Carolina at Chapel Hill, and I used to help lead a scholarship program that they have called the Chancellor Science Scholars. And one of the cool things about it is that they would come and spend the summer on campus, and all they would do is research, hang out with each other. It was like a bonding experience, and they would have a head start on understanding research at the university level. But we'd also like eat lunch, and I would love sitting down and eating lunch and getting to know the different students and to get different scholars. And I had one student, she she was talking to me and she was like, "Hey, you know how we like look at like animals, like dogs and squirrels or whatever, and we always like look at it like less than." And I was like, okay, yeah, like kind of where are we going with this? Because I could see in her face and the way she was laying out that she was about to just like try to present to me like this profound statement. And she said, soon that is how technology will like compare to us. And then everybody at the table, they kind of like stop eating and they're like, right? And that has stuck with me like for so long because I don't for as long as, human civilization has been there since we were hunter-gatherers, since the Industrial Revolution, right? We've always been like the apex of intelligence on this planet. And we're not necessarily that anymore. It depends on, if you say AI is intelligence or if it's artificial intelligence. I feel like we use these words to kind of like, protect our ego and our psyche, rightfully so. But that's a tough one. Do you like personally as a researcher like contemplate what it means to maybe not be the superior intellect like on our planet?
Absolutely. You know, I have two thoughts related to this. One is that all of the artificial intelligence systems that we're talking about, generative AI and any AI for that matter, were built by people. Um, and the generative AI systems like the conversational agents, large language models, that sort of thing, they're built on all of human intelligence, right? That we put on the internet. So yes, it's larger than us because the collective contributions of all people over all time for all research is larger than any person. And the fact is that we connected everyone around the world, or most of the people around the world, to the internet. And then we started collecting information there. And now we've built algorithms that can now pull some of that information back out. So yeah, that's bigger than us. That's why we use it. Because, if someone's asked me a question, I'm like, I don't know. I'm going to consult the bank of all the human information that was ever collected. So it should be rightfully a larger intelligence system. Now, does that mean it's more valuable than people? I don't think so. So that goes back to the basic question of what is most valuable to humans? It should be humans, right? So we have a society, like especially in maybe academics and research, that values intelligence as like the biggest contribution that people can make. But we have to remember that I can't do research without lunch. I can't do research. I can't come to my office without a car that someone helped make, or a bike or walking or something, right? I have to do there's physical infrastructure that helped me get where I am today. And none of this work happens without all the work that all the people are doing, right? People who pick up trash, people who clean things, people who make tables, people who make computers, people who make phones, people who support the internet. Like all of this is a collective effort together, and every person is valuable. So that is one side. And that doesn't make AI more valuable. It makes it more valuable possibly for a task. But we have to remember that people are the valuable thing. And I heard a program on NPR the other day that was about plant intelligence. And it was fascinating that they were talking about how plants learn and communicate and adapt to survive. And one of the points that the speaker, I think it was Zoe Schlanger, it was on NPR radio. I was in the car, happened to hear it. And I didn't hear the whole program. I just heard the end where she was saying, we have classically had this idea of a hierarchy of, humans at the top and all the other creatures, in between, and all the plants at the bottom. But, the thing is, as she said, we wouldn't be here without the plants, right? All energy that people use to do anything comes from glucose. Glucose comes from plants, and they take energy from the sun and they convert it into energy we can use. So there's no such thing as intelligence without a plant that got some sun rays and turned it into some energy.
A huge shout out. We're going to take a moment to put a plug in for plant intelligence because plant intelligence is amazing, right? They can converse and share ideas from one side of the forest to the other side of the forest through the underground root system, which also incorporates the use of fungus to help transmit information and nutrients. It is like mind boggling. And I was like, what? Avatar was real? Part of me was like thinking that, honestly. So, all right. This is so exciting. I'm trying to like contain myself really quick. I need to be like professional, like reporter, but I'm like, you're getting me out of my element and you're like making me. All right. So you talked a little bit about automation at the beginning. I feel like very rapidly these two worlds are coming together. I was at um, the Japan Society for the Promotion of Science. They had an event in DC and they invited, a whole bunch of people to just come and talk and converse about science. And, they invited me, I don't know if I was worthy, but, I was there. And I had this really great conversation with, I guess, the then director of the society, at least in DC. And he said, I don't even know if you're a robot or not. And he's like, I'm just joking. But he started saying like that is where at least he sees, things perhaps going where, artificial intelligence, which is continuously getting better and improving, meets automation, which is also getting better. Like sometimes I imagine, like, what if the breakthroughs at Boston Dynamics meet the breakthroughs at OpenAI? I mean, what does that look like?
Wow, that's a great question. So one thing I always fall back on when I'm trying to sort of understand what might happen in the future is the idea that, we often take the most efficient path, or the path of least resistance, I guess is another phrase that I remember from school, you know, um, that there's inertia and there's momentum, right? So there's a lot of automation momentum, and there's a lot of momentum in the sort of building of AI and sort of adding more information to it and making it better and connecting it even to more kinds of media, not just text. Um, so I think that is the future, and sort of that is what companies are wanting to do. They want to grab the innovations, but it's sort of historical that everybody wants to grab the newest technology and use it for their systems and things, but it doesn't mean it's the best choice. So we often do want to automate things, but we don't necessarily want to do them with the latest version of technology because, as I mentioned earlier, this latest versions of technology take incredible computing resources. It means that companies are going to have to pay, which they're probably already doing, pay to have everything on the cloud, pay for extra security for all their private information to be on the cloud. Then they're going to have to pay for the license for the AI engine. Then they're going to have to decide, like, well, how much of our proprietary information are we going to give to this AI engine so that it can tailor its intelligence to the tasks that we need to do? And so there's a lot more jobs that have to be done to automate tasks and to move them to the new version of the technology. And there'll be new waves of these technologies coming in the future and these automations. So automation is something that I was saying falls, in my mind, falls under the umbrella of AI in general, AI and algorithms like in general, but the new generative AI is a different kind of animal. Like automation can be done like I can build a mousetrap. That's an automation, right? Press the thing, press the cheese holder down and the trap comes down on you. That's an automation. So generative AI, though, is a specific kind of automation of a language generation task, right? And you can tailor it to do other kinds of tasks. And we've got self-driving cars. And so we've got this bridge between this sort of hardware and the software kind of stuff going on with the new machines. And I think that's kind of what you're getting at with the automation question. So are we going to have self-driving cars? We probably should. I've seen even years ago, I went to an amazing talk that was an introduction to the AAAI conference. I think it may have been in 2005 or 2006. And the person who gave the talk, and I apologize, I can't remember the name off the top of my head, was saying that they really wanted self-driving cars because their grandparent was stuck in the house because their bodies could no longer do the driving. And so since our society here is so bound to, using cars, it's locking some people out of being able to have freedom and autonomy. And so we need it. And then also, I've also seen lots of traffic simulations where if we actually allowed algorithms to modulate traffic, it could be more efficient, and it could also save save some accidents. Now, are we going to have some accidents? Yes, we have accidents with people too. So again, that comes down to needing to have a conversation. When do we allow an algorithm or an AI to have control? When we haven't answered that question. And if people don't understand how the systems work, we're not going to get the right answers. I mean, we're probably not, there's no such thing, I think, as the right answer. We're going to be making these decisions, and they're going to impact people's lives, right? Who and how people use devices, and, it's a big deal. So could we go into the future and not have self-driving everything? Yeah, we could, but we also will probably have something in between, right? I always thought in the Jets, like when I was a kid, we had the Jetsons, right? And they had hover cars, and we were all like, when are we getting our hover cars? But going back to that sort of, what's the minimal innovation? So we don't have hover cars because they cost a lot more energy to do. And in a similar way, generative AI costs a lot more energy to do. So if I'm like checking out with my shopping cart in an online purchasing place, I don't need a generative AI to tell me how much money I owe, right? I don't want to automate things with the tools that I don't need to automate them with. I would need to use a generative AI when I need to have a conversation, when I need to help someone search for information. But I should use our regular old stuff that's effective, that doesn't cost a lot of energy, a lot of extra energy, a lot of extra resources. And that's what we need to learn to balance. Like, if people don't learn about AI and what it can do and which kinds of AI should be used for what, then we'll actually make decisions to say, well, this is the new thing. I got to put everything on the new thing. And then you have to do a lot of work and spend a lot of energy for that, but it may not get you what you actually really want, which is, a better business or better relationships or, more efficient transactions or, make more money, which is what a lot of us want to do. But
Absolutely. And also, I was going to interrupt, but huge shout out to the old school game Mousetrap. Used to be my favorite, to get that whole thing to drop the mouse. I mean, the cage on the mouse. I've never actually played the actual board game. I just throw the board game aside and just play with the machine that, what is it called? A Rube Goldberg machine or something like that. Used to love it. Also, huge shout out for the Jetsons. And I don't know if people, have watched it in a long time, but
probably
due
not.
to the well, no, due to the fact that everything is streaming now, my daughter and my daughter's 8, right? And we watched the Jetsons, and on further review, I used to think the Jetsons was like entirely in outer space, but if you rewatch the intro, they're on Earth. Like, they zoom down on Earth, and I guess they're living on stilts off the ground. I don't know if they were trying to kind of forecast pollution or something. I don't know, but yeah, that's really interesting. The next thing, and if this is, I just curious because I haven't heard anybody talk about this yet, and I know the conversation is happening. I'm just ignorant of those conversations. But where are we at with quantum computing? Are we closer to moving from a theory to an actual reality? Where are we at? Because I'm thinking our AI is operating off of like standard binary, right? What happens when it starts operating off of principles of quantum computing? Am I off base? Like, yeah, help me out with that question.
Wow, it's been a long time since I looked into quantum computing.
Right.
Um, so I'm not a great person to answer that, but according to the internet, quantum computing is still in early stages. But
That's what I thought.
we have, I remember when I was in grad school, we talked about a lot of different innovations in terms of making computers with different abstractions underneath them. So the abstractions that we have right now that enable all the computing we're doing today are related to sort of translating values in the world into Boolean values, which are zeros and ones,
Yes.
and using memory that everything stored in your computer is stored in zeros and ones, and everything transmitted on the internet is stored in that way. And all the algorithms that we build, even though we often write programs with like what looks like sort of like natural language or programming languages, it's all translated eventually into these zeros and ones. And so quantum computing is an example of taking advantage of the properties of quantum particles to be able to do faster communication, faster computation using an entirely different abstraction. So what that really means is, in order to solve hard problems, we have to be able to map those hard problems into this new representation or this new kind of set of interactions and set of abilities. Like, what do quantum particles do? I'm going to probably be wrong, but I think what they do is, like, when you have a quantum pair of particles, if you do something to one, like, it is reflected in the other one, right? So a quantum computing system would be wanting to take advantage of that property, right? To have like more instantaneous communication, for example. But like I said, everything we have right now has been developed for Boolean values of zeros and ones. And to take big problems, important problems, and solve them with quantum computing, we need a lot of work to take the problems that we're looking at and translate them into things that can be quickly done with quantum particles. So I think we're not there yet. Like I said, the internet thinks it's, 2030, there might be 5,000 quantum computers. But they think it's going to be like several years after that before we can do hard problems with quantum computers.
Well, that feels like it's right around the corner. Like, all right, you want to see something it's kind of cool. You asked the internet. I asked Chat GPT, right? And this is the question, right? I want to hear what you think about this. All it was is, what happens when AI meets quantum computing, all right? And so I'm reading it for the first time. I have
Okay.
no idea what it's going to say. It says, when artificial intelligence, AI, meets quantum computing, the combination promises to revolutionize both fields, potentially leading to unprecedented advancements in technology and problem-solving capabilities. Here are some key points on what happens when these two cutting-edge technologies intersect. Quantum speed up, enhanced computational power, improved machine learning, advanced algorithms, optimization and sampling, data security, real world applications. And I mean, it goes into challenges too. The integration of quantum computing and AI is still in its early stages with significant technological challenges to overcome, including error rates in quantum computations, and the need for scalable quantum hardware. Developing practical quantum algorithms that offer clear advantages over classical algorithms is an ongoing area of research. So basically all it's saying, and I just wanted to just put that out there for the audience, anything that you're thinking is like amazing right now with artificial intelligence will seem rudimentary once quantum computing meets AI. Theoretically, because like you said, it's just a long way to go. Perhaps
Well,
too early to have even brought it up.
well, let me go back to something I said before, which is that each new innovation, like quantum computing or AI, has a specific type of problem that it's really amazing at solving. So the gist of what you just read from what happens when AI and quantum computing collide is that, well, we'll probably make a lot of stuff faster when we do it well. But the last part said, when we don't really know what's better than what we had before, we still don't actually know which things quantum computing is going to do better than classical computing. And we need to get better at understanding which kinds of technologies, which kinds of AI, which kinds of computing are really good for different kinds of problems. And then we need to build systems that only leverage what's needed to solve the problem that you're looking at. And that is a huge challenge. And I believe that goes along with the challenge of how do we build and propagate effective human AI collaboration, because we also need like different kinds of technologies to be leveraged at different parts of a problem solving process and for different tasks. And we also need humans sometimes to have inputs into problem solving, and we sometimes need AI to have inputs. And when we figure out how to assign the jobs and do that effectively, that's when we're going to be really, really leveraging AI the way we should, which is bring in humans, help humans solve really hard problems, have the AI do the part that it needs to do or that it's good at doing, and let humans, do the part that they're good at doing.
That is fantastic. And we are closing out here. This has been an absolutely wonderful, wonderful, wonderful conversation. And I could just talk to you for like 2 or 3 hours. But I know you have groundbreaking research yourself that you have got to get back to. But in this remaining, 5 to 10 minutes of, this conversation, I feel like maybe like in my ignorance of the field, I didn't ask like the question that you were waiting on. Is there anything that you wanted to say that perhaps I didn't ask, or maybe questions that you wish people would, ask more when given the opportunity to have these conversations in spaces like this?
Well, I've been thinking about something, which is, we're often working, in research to try to make advances, like try to make problem solving better. I'm always trying to make learning better, but it's usually in a specific context. And it's hard to make AIs that work across contexts, and it's hard to build education that works for everyone. But as we grow up, like who is building the systems that help us learn the things that we need to learn throughout our lives? So we have needs for lifelong learning. And AI is one of the things that can be used to build lifelong learning assistance, right? So let me give an example. A couple of years ago, a family member of mine was diagnosed with a new disease that none of us knew about. It's called liver cirrhosis. And the doctor did not say much about what that is, like maybe 2 sentences. So something like liver cirrhosis means that there's scarring in your liver, which means it doesn't have as much capacity to store glycogen, which is used for energy in the body. Okay, thanks. Right? So what does that mean when you go home? What does it mean about what you should eat? What does it mean about how you should exercise? What does it mean for stress and sleep and how long your life is going to be? So we have these huge, very important questions and things we need to learn for ourselves, for our own health, or for the health and wellness of our families. And nobody is set up to teach us about these things, right? It's no one's job to teach me how to take care of myself, right? Or teach me how to take care of my family, right? It is some people's job to work at facilities that do that, but there's a lot of time in your life, hopefully, when you're not in a facility. And there's a lot of situations where you need to learn something new, and you need to be able to make decisions, informed decisions about what you should do and how you should change your behavior if you want a certain outcome, like living longer. Um, and so what I see as the future for AI is that we need to start leveraging it to help individuals with the most important decisions that they have. And then I can't tell you, in my mind, the most important thing is how do I keep my loved ones on this planet and healthy and able to be autonomous and make their own choices and feel healthy as long as possible. And that is what we need to be making AI to do. So what you need is I'm envisioning a type of systems, I'm calling them chat learn for now, that you can just pull up on your phone and say, hey, chat learn, I just found out I've got liver cirrhosis, or so-and-so has liver cirrhosis. I want to help them. Help me make a plan to learn about this, to learn about how my behavior should change, and help me track it and help me get better. And allow these people to help me and see what's going on and, sort of protect my information this way. Don't allow anybody else to use this. Don't send my questions to your AI information collecting database, that sort of thing. And that should be in my pocket, and it should be planning a curriculum for me. It should be reminding me to learn more every day. It should be reminding me to set personal goals. It should be reminding me to change, like do the behavior change I decided on doing. It should be tailored to take into account human psychology and like that the fact that I can only change like one habit at a time and it takes about 21 days to do so. Should be leveraging all of that, and it should be tailorable for me, and I should be able to adjust it and have all the kind of control over it I want. So that's where I see the question that's not getting asked, I think, enough is how do we put these AI systems to work for individuals? They often are put to work for companies. They sometimes are put to work for schools, but they need to be put to work for us to take care of the people we care about.
Wow. That was powerful. That was good right there. Because yeah, I mean that is what's really important. You, myself, the people that we love and care for, right? That is how we should be applying innovations to make our lives better. That was great. That was great. Well, with that being said, I just want to say, like, from the bottom of my real heart, real emotions, not artificially generated. I just want to thank you not only for taking the time out of your day to be with us today and to talk to me about these very important issues, but thank you for being a researcher. Thank you for pushing the field forward. I'm very grateful to you as a father of an 8-year-old. Just thank you so much for what you do. I really, really appreciate it. Thank you for joining us on the Richard Watkins podcast. Thank you.
Thank you for having me.
You're very welcome.